Всім привіт! Мене звуть Антон Молдован, і сьогодні я модератор доповіді Джеймс Копліна про ООП – об'єктно-орієнтоване програмування. Ця доповідь для мене особливо цікава, так як я пишу на F# і використовую функціональне програмування прямо на роботі, прямо в продакшені. Додам, що я підготував багато питань щодо цієї теми з точки зору функціонального програмування, тому я гадаю, кінцівка доповіді буде особливо цікавою, тому не переключайтесь. І ще попрошу, задавайте питання, пишіть, задавайте питання в Discord. Я зараз переключусь на англійську. So, a few words about our speaker. So James Coplien is a father of organizational patterns and is one of the founders of the software patterns discipline. Also, he is experienced consultant and trainer in the areas of software design and organizational improvements. Lead author and product owner for Scrum book, and it is a most authoritative work on Scrum Foundation today. So James Coplien, welcome to the Conference Software Architecture fwdays.
Okay, Anton, thank you very much. You can hear me? Everything is fine?
Yeah, good.
Okay, good. It's a great pleasure to have the opportunity to speak to you folks today. And in this short talk, I'm going to give an introduction to a way of looking at systems called DCI. We had the pleasure of just listening to Eberhard's talk. It was good to hear him again. I was surprised the degree to which our principles align, that we focused on what the customer wants, that it's not about tools. And this talk is much the same way, though because we're all nerds, a lot of this I'm going to present through the eyes of technology, because we have this myth that that objects are just there, and this has been around since the 1980s, that all you need to do is make a list of the nouns in your domain, and those end up being the objects. It's a lot more sophisticated, and if you look at started programming, going back to Alan Kay, who invented the term and who invented the idea, the whole industry has gotten it wrong. And what we've been doing in our programming languages for the past many years, I mean, since Simula 67 or since Smalltalk in 1984, is really just abstract data types. It's not object-oriented programming. Abstract data types have some nice properties too, but they're not systems thinking. And so even though the principles that Eberhard and I were talking about are very much the same, I think the approach I'm going to be talking about is radically different than having bounded context. And unfortunately, we use some of the same terms like context. So I hope we don't confuse you too much. DCI was really created by Trygve Reenskaug, who also invented Model View Controller, with which a lot of you are probably familiar. And while Model View Controller solves the interface part of the problem, Trygve always wanted to solve the programming part of the problem, and we feel this DCI paradigm does this. I'll be talking about some quantitative research behind this. This is joint with the Rensselaer Institute of Technology. Were instrumental in that research. So what's the difference between abstract data types, as you find in languages like CLU, and object-oriented programming, as Alan Kay proposed it, and this DCI thing I'll be talking about? So in abstract data types, we talked about data and state and behavior. And Eberhard, for example, is talking a lot about encapsulation and hiding the data. There's no data in object-oriented programming. There's only objects. And yeah, I guess you can encapsulate an object inside of another object. But an object is like an actor, and it's no more a matter of separating function and data than I think about talking to a human being and separating their actions from their chemistry. There's no data in object-oriented programming. There's just objects. In DCI, we're pragmatic, and we say we're going to be doing object-oriented programming in these things called contexts. And the main large building blocks represent use cases. So they represent what we sell. What we sell in software is use cases. We don't sell classes. We don't sell bounded contexts. We don't sell objects. We sell use cases. Those are what generate value. So we want to administer those. We want those to dominate our architecture, just what the building blocks are of the data or the objects. It includes the real-time concerns. It includes what Grady Booch, who's kind of the father of architecture and object orientation, used to call mechanisms. So we want to give these use cases first-class standing. In abstract data types, the focus on behavior is on the object, or really it's on a module. So we're fascinated with modules, and we're told, you know, the whole game is about building good modules. Well, no, it isn't. I mean, modularity is for the sake of the programmers. What we want to do is capture the end user mental model in the code, so that the code supports what end users are doing. What Alan Kay was trying to do was extend children's minds into their laptop, into their computer, so the computer would be an extension of their mind and reflect their mental models. So in real object-oriented programming, we have these networks of objects that work together to solve some problem, like a child is solving a homework problem or a child is discovering the world around them. In DCI, we also have these network of objects, and we encapsulate these networks in something called a context. Now, I'm going to do all of this so far without saying the word class. So most techniques and approaches used today on classes. This is about thinking in objects. That's why it's called object-oriented programming. So, I mean, when's the last time you programmed an object? Now, if you're a JavaScript programmer, maybe you actually have. But in Java and in C++ and others, you know, we program in classes. We don't think in objects. We think in classes. So in DCI, we're going to be thinking more in terms of networks of objects. That's object-oriented programming, and that's what enables us to map onto an end user's mental model. Now, we're going to bring back classes because, yeah, domain analysis is important. And to understand the building of a discipline, you know, the bricks out of which we build the house is important. But on top of that, we need to structure the behavior, the use cases, the context. And that's going to be objects, and objects kind of cut across classes in a funny way. And this is a problem that object-oriented programming has been struggling with for 40 years. And we've seen all kinds of awkward solutions like aspect-oriented programming and method injection and dependency injection. And we finally cracked that nut, I think, with DCI. Abstract data types are compile time bound. Object-oriented programming is essentially about runtime binding. In DCI, we have an interesting kind of runtime binding that use case relationships are compile time bound. Well, why? This is extremely important because we need to be able to read a use case. Object-oriented programming is go-tos on steroids. If you have a method indication on another object, you have no idea where that's going to go when reading the code. It could go to any subclass in some hierarchy of classes, or any object that supports that interface. And so to follow the thread of execution and to understand what them does, that is to understand the use case, what we're delivering, is impossible. So what we want to do is to have the use case statically bound, but have these weak snap links of dynamic binding to the domain objects that will implement the guts of the system. And those can be runtime bound, but they're very primitive, very easy to understand. So again, the problem is that in a good business, we think in and deliver use cases. That's what end users want. End users, you know, we don't want to talk to them about here's the domain we're going to deliver them. We want to understand their domains by observing them, and then by innovating solutions that will go across several customers. and delivering the use cases that will solve those problems. And there's not much about. Some of them are long-lived, some of them are tens or hundreds of thousands of lines of code. That's just the nature of the business. So there's no need to break them down into little itty-bitty things. I mean, that's what abstract data types try to do, and that's why we're in some of the mess that we're in today. So we want to raise the level of discourse to the business, to be able to think in use cases. So if you look at your Java code and you have a use case like do shipping, where are you going to find it? So maybe even in your mind you had written a use case and gotten some nice tool or something. But in terms of understanding how the code works or doing discovery, this is hopeless in Java. Now, there are ways of organizing this in other programming language. If you're in JavaScript, maybe you actually have done object-oriented programming. You can do objects in JavaScript. With enough abuse, you can do it in C++. With enough runtime binding, you can do it in languages like Ruby and Python and so forth. There's one language in which we have found you cannot do object-oriented programming, and that's Java. It's a class-oriented programming language. So we need to go to the technology level to give us some technology to support this. Some examples. A programming language called Trygve, which we've created to be a pure DCI kind of language. But you can do this in other languages. So what we've been doing in Java is creating classes, and we focus on individual classes. Not only that, but if you're doing development, you're focusing on individual methods. You get one method building at a time, and then you put the methods together into a class. The class together into something, but your focus starts with the method and then the classes. Well, this is traditional Pascal programming. It creates a bottom-up procedural architecture. This isn't just pulling your chain, and I'm not just trolling you here. There's research out of the University of Helsinki by Maria Sinialto and Pekka Abrahamsson that has measured, and folks that use test-driven development up building architectures that have the coupling and cohesion patterns of a procedural architecture. So test-driven development will destroy your architecture because it's a way of thinking in terms of the individual methods and this dichotomy of procedure and data, where we're going to deal with one method at a time and get it working. So then, we put an interface. And the interfaces are useful, but in the end, it's about behavior. So the interfaces that we have in a use case for delivering an order are totally artificial. And so those are internal concerns. They are not the primary focus of the architecture. The focus is on its behavior and in getting the system to do what it needs to do so we can deliver that. We will have interfaces and a way of applying the knife and slicing things up because, it's good to build things a little at a time and to have loci of understanding. Our minds are only so big, and so we have to have some way of dividing and conquer. But the usual knife that we use for slicing big ones up is solely in the domain space or solely in the what's called the smart data space. Objects are called smart data, and we use our knife and cut up the domain. We have a ubiquitous language. Now, all these things are good, and doing domain analysis and understanding the building blocks is good, but that's an internal concern. We need to really have the system focus on what we're delivering to that end user, because that's where the value is. What we're trying to do with techniques that divide things up is reduce cost. What we're trying to do with DI is increase value, increase what the end user experiences. Overall value is a function of both of these, so you need both. But the object-oriented community has forgotten this external view. And this is why most software today sucks. is that the software does not really accommodate what the end user mental model is. And then there's this terrible thing called inheritance, which everyone was fascinated with in the early days of object-oriented programming. I think that most people who are sufficiently advanced in programming have learned how badly inheritance bites you. So, I mean, it can be used in very, very shallow hierarchies and in moderation, but object-oriented programming really has nothing to do with inheritance. So if we think in use cases and deliver in use cases, well, and you look at typical behavior of programmers or typical methods, there are two problems. One is that we write classes and not objects. So we're thinking of one class at a time, and it's a data locale. So we have this data procedural dichotomy. It's very, very difficult to maintain that focus and to be able to think about the system structure or the case. And use cases, I mean, use case is not Swedish for scenario. What a use case is a collection of related scenarios. So if I'm going to, ship an order, well, maybe the shipment will be late. Maybe the truck is full. Maybe it's a change of address in the middle of shipping, or the person isn't home, so I need to read somewhere else. All those will be part of the same use case. And a use case is a way of talking about and structuring those related scenarios. It's what the business needs to have work in order to do what it's going to do. So in order to implement a use case, because after all, that's what we're delivering, we need to keep switching context between our primary focus. So we'll be working on this class a little bit, doing a little TDD over here. Then we do a little bit of TDD over here, and we switch back and forth. Context switching is the death of efficiency in programming. So yes, it's important to give one team one thing to do. So Eberhard was absolutely right about this. He's absolutely right about the research, where the way that you get efficiency is by breaking down this context switching between individuals. The problem is, what we tend to do is have a team and say, you work on this class, you work on this class, you work on this class. And now there's terrible, communication between the team, or this need for coordination, because the team is not thinking with one mind. Each individual's mind is in their own class. Or if the whole team is swarming and they work together, or pair programming, the two will work on one class, and now they need to switch contexts and work on another class. And that context switching is measurably expensive. We'll show you the research later. We've measured this. So this is the first problem. The second problem is that we focus on one object at a time. And I mentioned this. This is, the TDD problem, or the fact that that people still do unit testing. Unit testing was a great thing in the day of Fortran and Pascal, because for a given procedure was part of the behavioral architecture. And you would take a use case and break it down into procedures, trace what a procedure does all the way up to the requirements. You can't do that in object-oriented programming. The behavior is emergent. That's what object-oriented programming is. So it's nonsense to test in method. It's waste. And again, the research that shows this is true. The other thing is that polymorphism, like I say, is the galactic go-to. So if you invoke a method, your understanding of the code's functionality stops there, because looking at the code, you don't understand where that polymorphic call is going to go. So you can't just go there and read it to understand the code. We're focused to look at one class at a time, and going beyond that is a problem. In a very early paper, this was published in 1968 by Alan Kay, he says, what a child is doing is trying to solve a problem, and this is in terms of algorithms. And the way that the human mind works is this algorithm flows through several objects that work together to try to solve some problem. And Alan Kay became very disappointed And in fact, at one point, even suggested burning all the Smalltalk tapes. And Smalltalk was one of the good ones. You don't want to hear what he had to say about C++. And he says, if we look at the whole history, we see that the proto-object-oriented programming stuff started with abstract data types, had a little fork, what I call objects, and that led to Smalltalk and so forth. But after the little fork, the computer science establishment pretty much did abstract data types and wanted to stick with the data procedure paradigm. So nowadays is object-oriented programming. To illustrate the problem, let me do a little test. So I'm going to give you all a test. So here on the left, there is a little driver program, and the driver program we're going to run. And here are some class hierarchies. So there's an orange class hierarchy and a blue class hierarchy and a green class hierarchy. And instantiate, we're going to instantiate objects from the classes in that hierarchy. My erase, there it is, good. My erase button disappeared. So let's run this little program. So here we instantiate an orange object, and the program runs a little more, and we instantiate a blue object from this class down here, and we instantiate a green object from this class up here. And now we invoke the foo method on this object. So where does the program counter go? Does it go here? Does it go here? Does it go here? Do you remember? You don't remember. So we don't know. We don't know where it goes. And now that object calls the method bar on the blue object again. Where does the program counter go? We don't know. And that one, the method sna on the green object, again, we don't know where the program counter goes. We've lost the use case. We can understand each object individually, but we don't understand the thing that we sell. So the question is, where is the use case? Well, there it is. It's distributed across all these classes. Now, this is the thing we care about. And from, I don't care, you can call it an architecture point of view, you can call it a business point of view, you can call it a service point of view. This is what we care about. This is what has to work. So we want to give focus to this and make this be the context that we work on. So what we do in DCI is we take all this use case logic and we pull that out into a context. We wrap this in its own context, which is encapsulated. Now, this thing has no data. It's pure use case. Each one of these will be described as a role in the use case. And each role will have methods that describe what they do together to achieve some overall business goal, the goal of the use case. And this context represents that use case. So we now have architectural units or design units that reflect use cases. What are these down here? Oh, we still have our domain hierarchy in the sense of domain analysis. You should find it in the Neighbors paper in 1964, not in the sense that domain-driven design uses it. There's no domain analysis in domain-driven design. It's design. There's no analysis in DDD. You go directly from the outside world to code. Good understanding, I mean, analysis is what leads to understanding. So doing the analysis of the use case and factoring out the common parts and doing an analysis of the domain are what domain analysis is about. So now we can run this use case. So let's run the program again. So again, we run an orange and blue and green object, but these objects are devoid of the use case logic. Now we go to the context. We instantiate the context and say, please run this context. And what the context does is injects the role logic into suitable objects that will play those roles. So the objects are down here. And what we do when we run the use case is we tell the use case, all right, here are the objects going to play this use case. So here's an object that represents the thing we're shipping. Here's an object that represents this customer. Here's an object that represents the shipper. Here's an object that represents the manifest. And then we say, go. And what happens is that it will go and execute the use case logic in each of those objects. Because they've been infused into those objects, they're going to use the local small methods that just, retrieve the serial number of the part or retrieve the balance of the invoice. They're very, very primitive operations. They really don't have architectural or design significance. They don't really need to be tested any more than you test an if statement in your programming language. Now we can our domain knowledge in the architecture, but also focus on what we deliver. This is called the data, context, and interaction paradigm. Here is some sample code in a programming language called Trygve. You can get the Trygve environment. It's on, maybe I can post in the chat here where to get it. So it's just on GitHub under my account, and it's under a project called Trygve, and it's written in Java, so you can download this and play with it. The main building block for use cases is a context. So a context corresponds to a use case. So here's a context. This is a context for transferring money between two accounts. It has a couple of roles. One is the source account, another is the destination account. There's actually a few other roles too, like the balance. So here's a role called destination account, and it has a method called transfer from, where we're transferring from the source account. We don't need an argument to this because the source account is also inside this context. So all these players, these actors in the use case are global to the context, and they just refer to each other by name. So here transfer from says on this, what is this? This is the name of the object currently playing the destination account role. So go to that object and balance the amount that is part of this use case. We say that this role requires the role player to have these two methods. And in Trygve, this is checked at compile time, completely type safe. Here's a constructor. When we build a context, we give it an amount, we give it a source account, we give it a destination account. These statements are magic. When we say source account equals source, what it does is it injects the methods of source account into this object called source. And whenever we refer to source account as a name, it will refer to that object or to methods of source account. And we do the same for destination account and amount. To kick it off, we just go to the source account and say transfer to, and the rest all happens fine. Here's the source account, and here is really the core of the use case. I mean, this is just like Fortran. I mean, I can take this to a banker or to an account holder and ask them to read it, and it's very readable code. If I were to do this in standard class-oriented, the cohesion of the architecture would be terrible because I'm bound statically to an abstract base class. Here, the polymorphism takes place really via allomorphism. So there's a many-to-many mapping. We don't have a strict hierarchy, but it rather uses duck typing. Now, it's perfectly type safe, but by using this duck typing and using networks of objects rather than hierarchies of classes, we can capture the complexity of the real world. Most object-oriented programming is hierarchical, and every time they try to do networks, they get in trouble. And this has been the historic discussion with aspects and mix-ins and dependency injection and so forth. DCI is a way of slicing a knife that faithfully represents the complexity of the real world and does polymorphism in a way that everything just works out. So this is a straightforward use case. We say begin transaction. If this available balance, that's just an ordinary instance method, is less than amount, that's a roll. Then end the transaction. On the object playing this role, decrease the balance by amount, go to the destination account and tell it to increase the balance by the amount, update the log, and then tell the destination account to update its log, display success, and then end the transaction. And again, the source account requires that the object playing the source account has these three methods. So I still have my domain model. So I have an account abstract base class, and I can have checking accounts and deposit accounts and all different kinds of accounts. And this is just a standard class. So this is just kind of standard Java. So this is where the data are if you have this data dichotomy. There's no data in a context. So it's pure think data flow or pure functional programming. There's no data in a use case. There's no branching in a use case. They're data flow. So this is how business people think. And this style of programming better matches their expectation. So in DCI, we still have classes with their data because the domain model in the neighbor sense is very important. And the context represents the network of connections for use of interacting objects. And these roles, which kind of look like abstract base classes, except they have methods that really do stuff. So I mean, Java tried to do this in introducing these abstract base classes with methods, but I mean, they blew it. It doesn't work. You're still hopelessly compile time bound. Here, the roles dynamically can be injected into the objects at runtime. Now, how to do this in Ruby, for example, is straightforward, or in a good language that has a good reflection API. We have not found a way to do it in Java. There is a way to do it in C++ with templates. And there are DCI bindings for most popular languages that you can find. Let me wrap up with some research results. So I've created a pure object-oriented programming language, kind of with Java syntax. So it becomes more virus-like, easier learning curve. This is what you can get on GitHub. And the folks at RIT did a controlled experiment where they had one team doing Java implementation of a problem and another one doing a Trygve implementation of a problem. And the results indicate that DCI code in Trygve supports higher comprehension regarding correctness. So there's far focus on testing software. And this isn't just an object-oriented thing. Testing never improved the quality of software. Testing is only a very meager statistical measure of the current quality of your software. What we want to do is understand the code so we get it right. And the research shows that DCI aids a comprehension. It also increases locality of reference. So we avoid the overhead of this context switching, and that reduces the solution time and again, helps understanding. So just quantitatively looking at some of the numbers, These are means of correctness scores. Basic comparing Java and DCI. And I mean, here we have the statistical properties are staggeringly good. These are statistically significant results where the DCI code is consistently more correct than the Java code, all other things being equal. And in terms of context switching, asking people, you know, where do you spend your time? Where's the focus? What is the oracle of what the system should be doing? Do you have agreement on the most important central module? And in Java, this is true less than 2/3 of the time. In DCI, it's true almost 100% of the time. So there's this notion of having focus and understanding where I need to go to solve a problem, and of reducing the overhead of context, which is extremely costly. So last slide, much of the original object vision that Alan Kay had has been lost. Smalltalk destroyed it. Java really destroyed it. And C++ put the last nail in the coffin. DCI restores the ability to express this original vision, which is about people. It's about human mental models. It's about extending the human mind into the computer, not just throwing something to the computer and then doing procedural programming to kind of knit it all together into something which otherwise might be called a context. DCI is available in a broad spectrum of programming technologies, and the empirical results are encouraging. I think there's some research to be published where they actually did some psychometric studies based on eye motion, but I haven't seen those yet. So thank you very much. That concludes my talk, and I'm very happy to do this.
Thank you. Thank you. Okay, so now we're having Q&A session for about 8 minutes, I believe. So James, you mentioned a very interesting thing about code reasoning, context switching, you name it. And my question is about roles. It seems for me, correct me if I'm wrong, but it seems for me that in your role definition, you actually separating data from the logic. And it's actually remind me, if it's true, it's actually remind me just functional programming, where you have just data and you have modules with function that operate over this data. So the question is, what is role? Is it true that it's just like function flow that just separated from data?
No, it's not. I mean, roles represent psychological entities in the human mind. So again, in terms of a good domain analysis, you're going to understand how the end user thinks. So Eberhard mentioned CRC cards. I love CRC cards. CRC cards actually were invented by Rebecca Werfsbrock, and she renamed them our cards. Responsibilities and relationships. So when she was using these, she was thinking roles. These are business roles. And so the roles are not functions. They're not data. I mean, they're aggregates of behavior. So a role like account, or there was one called amount, I think. Is that a function? Is that data? Well, that depends on the implementation. But people who program in Java or in C++ have this data procedure dichotomy. If you've programmed in Eiffel, for example, that dichotomy doesn't exist. So whether you bind a method as a piece of data or as an algorithm is a very, very low-level programming decision. So, I mean, you're in hell and asking this program. You're unable to think in objects. You're thinking in classes. So DCI is about thinking in objects, and the roles are just the names of those objects. And then the objects are what they are. And I mean, if you implement them using fundamental mode logic without any state, I mean, that's fine. There's not even any need to have data. Data is a low-level optimization. So this, I think DCI transcends your question. It's a completely different paradigm that does not depend on this dichotomy between function and data.
Yeah, got it. So it just for me, at least, when I looked at the code that you showed, I see just functions. I don't see the data there. I see some manipulation, some, I don't know, for example, end transaction, some validation, update log. But for me, it's just like kind of functions flows. So not real. There is no definition of data. Maybe I'm missing something, but okay. I have another question to you. Are Goff patterns still good to learn on this, or there is some modern alternative?
So first of all, to your last point, there were data in my code. Amount is data, right? It's in the code. Or is it data, right? So, I mean, it's there. Just, I don't know why you didn't see it. But look, read the code again. It's there. Okay, in terms of the Goff patterns, number one, they're not patterns. Basically, what they are, if you read, I can't remember, a latter chapter in the Goff, these are basically, they took the idioms from the Advanced C++ idioms book that I published back in the 1990s and made them language insensitive. And then they added a few more from research. I can show you a couple of quotes from one from Eric Gamma and the other from Richard Helm that says there's not a single pattern in that book. And I mean, if they were to redo it, they'd do it completely different. So, I mean, they're the good low-level programming tricks that a C++ or Smalltalk programmer has to do, but they're low-level coding tricks. They're irrelevant for design. I can teach them in about an hour. I think anyone who's focusing on Goff patterns for design just simply does not understand programming.
Okay, another question from Discord. You mentioned that user cases are statically bound. What about systems that allow users to program the system itself? For example, Excel, and that allow users to create their own use cases. And Alan Kay's idea of object-oriented software allows for this, but it becomes messy quickly. And what about DCI look like in a user programmable system?
Well, to understand this, you need to be a little more mature and jump out of object-oriented programming. I mean, a good programmer has many paradigms at their disposal. They have rule-based programming. They have programming. They have programming bases. They have procedural programming. DCI is for problems suitable to object-oriented programming. And for using object-oriented programming, you'd better understand to what problems that is suitable. So if I'm doing Excel and I'm using object-oriented programming, I'm an idiot. I mean, you use rule-based programming. You use a completely different paradigm for your understanding, for your modeling, and hopefully for your programming. So, I mean, one size does not fit all. And too many object-oriented programmers are like hammers, and everything looks like a nail. And they're going to apply object-oriented programming to every problem. And then they try to apply it to Excel, and they say, "Oh my gosh, you know, this doesn't work." Well, of course it doesn't work. You're using a hammer. Use a saw. So there's a level of maturity of software engineering here that requires moving beyond, you know, what your mother told you. Most of what your mother told you in university is wrong. You've got to think and broaden your knowledge beyond what's in the books and beyond the pablum that the industry has been feeding us for the past 40 years.
Okay, I see. So it seems we're coming to the end. We're actually having maybe one minute. So let me ask you one question regarding code reasoning. your code that you showed, and it's about your language, yeah? So do you have something like expression and statement, and do you have any kind of can you evolve, can you talk about this a little bit more? Because in your examples I see that there is a lot of statements, but the thing is with statement that it's quite hard to reason. They are not returning nothing to me. So how your language actually is addressing
there
this?
actually is a manual for the language, and I'm happy to send that to you. And I mean, the manual comes with the GitHub release. I consciously made the syntax to look like Java to encourage people to dive in and to try to invent with it. But if you look at the grammar, there is no such thing called a statement. All there are expressions. So, for example, the expression if returns a value. So if I say if conditional, then one else two, that is a value. And I can use that expression anywhere that an R value can be used. So I can use this as a pure function or pure applicative language, in fact, by torturing the grammar. It can implement Java grammar kind of as a degenerate case. But yeah, it's a pure expression language.
Okay, so we are running of time. So thank you, James, for this very unique and very helpful talk. Very interesting. So now it's time to move on. And guys, we are going to jump on Discord, and we'll see you soon. Cheers.
Tell me where to go on Discord.
Yeah.